Last video of this sequence, I need to talk about what the derivative of an unnatural logarithm is, and then a little bit of math humor. Hope you enjoy it. What I mean to say by that is we totally already know what the derivative of natural log x is. If you have a natural logarithm, the derivative is 1 over x. Right? But what about when you have an unnatural logarithm? In other words, what happens when we've got something like the derivative of the log base a of x, some other base, some non-e based logarithm? And there's a formula for it. The formula for it just says that it's 1 over x times the natural log of a, right? Another way of writing that is that it's 1 over the natural log of a times 1 over x, because I do want these things to be connected to one another. I want you to see that the derivative of any logarithm is effectively 1 over x. It's just that when it's a log base a, you also have to multiply by this 1 over ln a thing, right? So let's take a look at a couple of specific examples of that. Suppose that I asked you to take the derivative of the log base 7 of x. Well, the log base 7 of x, let's see here, so that would just be 1 over x times the natural log of 7. Or you could write it as 1 over ln 7 times 1 over x, right? Either one of these answers is correct. They're both good. Now, right now I have to let you in on a little secret. I'm not sure that we really need this rule. And the reason is we have a change of base formula. Like, if we're so happy with natural logarithms, if natural logarithms are so much easier, if they don't require us to memorize this thing, why not just take this statement? Why not just take the log base 7 and rewrite it with a base of e? Why not just say, you know, this problem really means the same thing as ln x over ln 7. And if you forgot your change of base formula, take a minute to make sure that you process that these two things are the same as one another. Because once you have that, it's sort of like, well, wait a minute, ln 7 is a constant, right? Couldn't I pull that out front and just say, what's the derivative of 1 over ln 7 times the natural log of x? And because 1 over ln 7 is a constant, can't I leave that alone and just do the derivative of the ln x? Don't I just get 1 over ln 7 times 1 over x? And is that not the same as what we got up above? So on the one hand, yes, this formula is nice, and it's good because it means you don't have to remember this manipulation thing. And so I think I'm going to stick with it. I think I like us knowing this formula, but know that you can also get through these problems by using the change of base formula. You will get to the same place both ways. Let me write down one more easy example for you, and then we'll get into some things that are maybe more interesting. So if I have let's say that f of x is the log base 11 of x squared minus 3. Remember, this is a derivative, which means the chain rule and the product rule, all those things still apply. So for a problem like this, if I was going to take this derivative, well, it's a log base 11, so I start with 1 over ln 11 times, and then I treat it like any other logarithm derivative. The derivative of a logarithm is supposed to be 1 over the thing that's inside times the chain rule, times 2x. So if I were to try and pretty this up a little bit, I would probably say 1 over ln 11 times x squared minus 3. And I just realized that I actually don't want to put 1 over. What I'd really like to put is 2x over, because we could put that 2x on top. So 2x over ln of x squared minus 3, and that's our derivative, right? I think I've got 3 other examples that I'm gonna go through here. The first one is a product rule example, and the last 2 examples really are important, so don't just stop now. There's an important thing I want you to remember. You know, what happens if I have g of x equals x squared times the log base 3 of 1 minus 5x? Well, again, you heard times. This is x squared times that. So g prime of x will be, the derivative of the first thing is 2x. We leave the second thing alone. Plus, this time I'll leave the x squared alone, so x squared. Now the derivative of this, that's the new part of the lesson today. It's a log base 3, so I start with 1 over ln 3. Then it's a logarithm, which means it's 1 over 1 minus 5x. And because that 1 minus 5x wasn't just x, we need the chain rule, which gives us a negative 5 at the very end. To be honest, I don't think there's very much you can do to make this prettier. I'm just going to sort of make that second term a little bit nicer. Let's see, what would I do? I guess I would put the 5x squared on top, and on the bottom I would just do this, ln 3 times 1 minus 5x. And I suspect that's about the best we can do. And again, I'm not going to lie, that's terrible. That's a really, really, really long derivative. But we can do it. If you want to see a problem to be scared about, take a look at this one. And it's actually not frightening at all. And I want to remind you of why it's not frightening. If I gave you h of x equals the log base 2 of x squared times the square root of 3x minus 1, like all of that's inside the logarithm. At first you're scared because you're like, wow, that's a crazy chain rule problem, and it's a log base 2, this is bad. But remember logarithmic differentiation? Remember the idea that when you have a log and then things multiplied, or a log and things divided, I don't have division here, I'll have that in the next problem, you can split up the logarithm, right? That doesn't just apply to natural logarithms, that also applies to unnatural logarithms. So your first step here is don't take the derivative. Your first step here is to say, look, this is just the log base 2 of x squared plus the log base 2 of the square root of 3x minus 1. Right? And remember, we can do even more than that. We can bring down powers as well, still not taking the derivative. H of x is 2 log base 2 of x plus 1/2 because a square root means a half power, 1/2 the log base 2 of 3x minus 1. Now that these things are so simple, I can take the derivative. H prime of x will be 2 times, now because it's a log base 2, I have 1 over ln 2. Because it's a logarithm, I get 1 over x. And because the thing inside was just x, I don't need a chain rule here. Okay? Plus the 1/2 constant, the 1 over ln 2, because it's a log base 2, then the 1 over 3x minus 1, because it's a logarithm, and finally the times 3, because of the chain rule. The thing that was inside was not just x, it was 3x minus 1, so we need that. Some simplification could certainly be done here. One thing I might really be inclined to do, having these logs around is sort of a mess. You might want to factor out the 1 over ln 2, and then the stuff you have left is just 2 over x plus, let's see here, 3 over 2 times 3x minus 1. As a final comment here, you could distribute this out. We could get a common denominator here. It's not, if it's a multiple choice, you may need to make it match. If it's free response, I'm pretty happy with this answer. I did have one other problem planned, so I'll go ahead and go through that one. If you know you've got the hang of it already, you might just want to look at the intro to this problem to make sure that you remember it, and then if you feel comfortable with it, you can get started on the homework. So the last one I have is, suppose that we had the function log base 3 of x cubed over sine x. Actually, I want to change that problem. I think this will be a more interesting problem if I do this. There we go. X cubed over 9 to the x. I hope this problem is going to work the way that I want it to. I think it will. The plus this makes the problem a little bit scarier because 9 to the x is a more challenging derivative on its own. But remember, because this is a division problem, we can split it into the two pieces. So I could certainly make this the log base 3 of x cubed minus the log base 3 of 9 to the x power. Great, but then simplify more, right? These powers can all come down. Still haven't taken the derivative yet. This is 3 times the log base 3 of x minus x times the log base 3 of 9. And that right there is, I hope, where this gets interesting. I hope when you guys see the log base 3 of 9, you remember that that's 2. Right? So I'm kind of not going to take the derivative again. I'm going to simplify this further by saying it's the log base 3 of x minus 2x, because really that's all that is. Then I've just got to take this derivative. F prime of x is 3 times 1 over ln 3, because that's what we do with a log base 3, times 1 over x minus, and the derivative of 2x is just 2. Right? The last step that I could take in making this prettier would be just saying it's 3 over x ln 3 minus 2. And that's the end of this lesson. It ended up being longer than I wanted it to be, but I do hope that you guys will have a little bit of energy left and maybe try one of each of the problems in the homework tonight. Try them out. Just make sure you got the hang of it before class tomorrow. I'll see you then.